So we're going to have a final exam, and we're going to be asking a lot of you. We're going to be asking you questions over the entire year, the time when we were in school and the time when we're not in school. But the good news is, as we've done with all of the other major assessments, the other benchmarks this year, the test will be on Get More Math, and you'll have access to the questions before you take the exam. What you also have access to is what I'm looking at right now, is the study guide broken out with notes already created by me. So I'm going to try to help you out as much as I can. Pausing and making you write all this in would take a long time. So let's dive into the content itself. Otherwise, this video is going to be half an hour long, and neither one of us wants that. So you should have in front of you the handwritten version of the 10 questions, or the first 10 questions for the study guide part 1 of 3. We're going to have 3 videos total over the course of the next 3 days. So here comes day 1. I'm going to dive right in, or we're going to be here forever. Question number 1 is going to deal with, or a style of question like number 1 is going to deal with an equation that you need to solve. You have all of the answer techniques here on the side in the order in which you should complete them. Simplify both sides. You should be distributing, and you should be combining like terms. In this first one, we get negative 11 plus 241 is a like term pair because they're both numbers. So we're going to combine those up and get 230. On the other side, we need to distribute first and then combine like terms. Now, step number 2, if you have any, you do variables on both sides. You get rid of the smaller variable. We don't have any here. We only have a single variable, so we just move on. Step number 3, on the side with the variable, eliminate the constant. And the constant is this number right here. There's 2 numbers on the side of the variable, 72 and 79. This is called the constant because it's all by itself. The thing that multiplies the variable, it's not called the thing, it's called a coefficient. So we're going to deal with the 72 first, then we're going to go after the coefficient. 72 is positive, so I'm going to subtract to get rid of it. And I do a little, I don't have a calculator here, so 13 minus 1 is 12, and 10 is 8, and 5 and 1. Let's make that 5 look a little bit better. And we have 79C. Now we're going to go ahead and get rid of step number 4. On the side with the variable, eliminate the coefficient, and that's the 79. It's, in this example, being multiplied by C, so I'm going to divide. The 79s cancel out, and 79 goes into 158. I know from past experience it goes in 2 different times. There are no special cases in this particular example. Special cases only come up when you have variables on both sides. And what the special cases show is if you find yourself with 2 things that are exactly the same with an equal sign, like 5 equals 5 or 10 equals 10, then you call that an infinite number of solutions. However, if you have 2 things that are not the same, like 5 equals 10 or 2 equals negative 12, then that is a no solution problem. That didn't come up here, but it could come up, so if it does, be ready. Question number 2, 3, and 4 all deal with, if we were in our classroom right now, I'd be pointing over by the water fountain and pointing at those rules that I had written on poster board. We don't have that, so here we go. We have the 5 rules that I have written down, and each of those rules breaks down to combining things on top and bottom of a fraction. So these are the base 6, so that's this first rule. Since they're the same base, we're going to go ahead and add the exponents. 3 plus 6 is 9. And on the bottom, we have a different rule. We have a power to a power. That's this rule. So power to a power is 8 times 2 is 6 to the 16th. Now I have a fraction top and bottom. Of course, that's a fraction, right? The only thing here that looks like a fraction is the second rule. The second rule tells me to subtract my exponents. So in this case, 6 to the 9 minus 16. 9 minus 16 is negative 7. Fantastic, except now I have a negative exponent, and that's rule number 5. Negative exponents are illegal, so we're going to go ahead and do what rule number 5 says, which is flip it over and make it positive, and now we're done. Lots of stuff going on there. Question number 3, a little bit simpler. I have everything just in a single straight line, which means primarily I'm going to be using the first rule and then maybe using some other stuff. So let's deal with the x's first. There's only a single x, so I'm just going to write that in my answer. As for y's, I see a y here and a y here. So I have y to the negative fourth and y to the third. And if we're using this first rule, I add negative 4 and 3, and I get y to the negative 1. Now I'm left with z and z. Same rule, negative 5 and 2 make negative 7. And now I have a line of stuff, but some of them are negative exponents. So I have to, for those things that have negative exponents, I need to flip them. So the x does not have a negative exponent. So the x stays where it is. The y has a negative exponent, so it flips down to the bottom and becomes y to the positive 1. Remember, you can write the 1 there if you'd like to, but because it's 1, we don't need to. And the z, it has a negative exponent, so it's going to flip down as well, and I get z to the positive 7. Everything's positive. There's no extra letters around that are the same as other letters. We're done. And number 4. Same idea as number 1, it just has variables instead of numbers. The top values are y to the first and y to the third, so I get y to the fourth. On the bottom, I have y to the first and y to the fifth, which is y to the sixth, and that pesky z to the second, which doesn't really seem to go with anything else. So since it doesn't go with anything else and it's not a negative exponent, it just goes right along into my answer with no other need to look at it at all. It doesn't have a negative exponent. There's no other z's. It's just going to sit there on the bottom like it had the whole way through the problem. As for the y to the fourth and y to the sixth, since I'm subtracting them using rule number 2, the answer comes out on top. So 4 minus 6 is negative 2. And once again, you have a problem with a negative exponent. Whatever has a negative exponent has to flip. So in this case, the only thing that flips, definitely not the z to the second, the only thing that flips is y to the negative second. It's on the top, so we move it down to the bottom. You've done enough math that you know you can't just leave blank divided by the answer. So we're going to put a placeholder in there, and we're done. Right? There we go. So exponents, all wrapped up. There's the rules. You can reference those rules as you move through Get More Math. Next up, we have a whole series of blue problems in scientific notation. I tried to write these out because scientific notation is something we haven't done for a while. First, choose the correct scientific notation for this number. A little reminder up here, scientific notation numbers always have a number in front. It could be positive or it could be negative. That number is always going to be between 1 and 10. So it might be like 2.9 or 3.7 or 7, but it won't be 10 or more, and it won't be less than 1. It'll always have a times, and it'll always have a times 10. That's just how scientific notation works. And the number up above the 10, the exponent, will either be positive or negative. If it's positive, then the original number was 1 or more, usually like 100 or 1,000 or 1,000,000, something usually pretty big. And if that number up there as your exponent is a negative exponent, that means just like we did with exponents. You would have flipped it to the bottom. That doesn't make it negative, it just makes it tiny. So if that exponent up here were negative, then the original number was somewhere between 0 and 1. So 0.02 or 0.0009 or something like that. All right? So here we go. In this one, I want my decimal to be 6.82 because it follows the first rule. It has to be between 1 and 10. And it's a really, really teeny tiny number. I'm going to remember that. So first and foremost, my decimal that goes in the beginning of the problem should be 6.82 because I need a number between 1 and 10. I always have times 10. I have a really teeny tiny number between 0 and 1, so my exponent will be negative, and now all I have to do is count the number of times my dot moves. So this black dot to get to the pink dot spot would be 1, 2, 3, 4, 5, 6, and 7. It moves 7 times, so this is the correct answer here. That's how scientific notation works. A note here, with quasi-scientific notation, something that looks kind of like scientific notation, like this guy right here. Scientific notation has particular rules where that first number has to be between 1 and 10. If it's not between 1 and 10, it looks like scientific notation. It's quasi-scientific notation, quasi meaning kind of like, but it's not scientific notation. So we used, in my class, we used the arrow technique. If the number was too big, I made the arrow go down. If the number was too small, I made the arrows go up. And then we always had them kind of opposite of one another. So check out this problem. I have a multiplication problem. 3 times 10 to the second, 4 times 10 to the third. So I take 3 times 4 times 10 to the second times 10 to the third. There it is. 3 times 4 is 12. 10 to the second times 10 to the third is 10 to the 2 plus 3. There's those exponent rules again. So we find ourselves getting this thing, which I'm going to give a flat face because I'm happy, but I'm not that happy with this answer. I have 12 times 10 to the fifth. That's good, but not great because it's not in scientific notation. So the 12 is too big, so we're going to decrease the 12. And if I decrease one thing, I have to increase the other. So 12 drops down 1 decimal place to 1.2, and the 5 goes up 1 place to 6, and now we're happy. 1.2 times 10 to the 6th is the correct answer. All right, that's this one. That was just a sample. Actually, I'm going to let that sample ride because that sample will help you answer number 6, and this video is going to be long enough, so I'm going to say number 6 is one you should be able to try on your own using the techniques that I have there under the multiplication and the quasi-scientific notation example. And with division, same idea with the quasi stuff. We might still end up with an answer that's not quite scientific notation. However, all we have to do is pay attention to division. So instead of doing this problem completely, I made up my own. If I have a division problem where it asks for 4 significant digits, which is what it normally will, all you're going to do is take your initial numbers and you're going to divide them, and you're probably going to use a calculator here. I used a calculator and I got 0.46875. Okay? Now we're going to go ahead and do the second piece, which is an exponent rule. We've already been over those. Exponent rules for fractions are top exponent minus bottom. So -3 minus 10, that's how I get this part, and that's where this part comes from. -3 minus 10 is -13. And now we come into the quasi-scientific notation piece yet again. This number right here is not between 1 and 10. It's too small. So we need to make it bigger, so arrow up. But if I make that one go up, the other one has to balance it and come down. So the -13 goes down. -13 goes down to -14, and now we have ourselves a pretty good looking answer. However, Get More Math's very picky. They want their 4 significant digits, and you and I can both count. I got lots of highlighting here. Let's take just a moment and clean up a little bit. Get back to neat. You and I can both count. I got 1, 2, 3, 4, 5 digits. 5 digits is one too many digit. So what I'm going to do is focus on the first 4 digits and then look at the one I haven't highlighted. That number 5, that one tells me whether I round up or stay the same, which is to say round down. And 5 or above, I give it a shove. So look at my answers in my answer. 1, 2, my answers in my answer. My numbers in my answer. The 4, the 6, the 8. Instead of 7, it rounded up to 8. That's 4 significant digits. And now I have my answer. Right? Now we are happy with what we've got there. Now, last 3, I guess. The number 8 I have in purple. Classify this number. Now, this particular one is pi. You could have a variety of different options here. So I made you some very generic notes that you can remind yourself of. Rational numbers can be made into a fraction using integers. That's what defines rational numbers. And I have a variety of different rational number examples here. These are all numbers that are either fractions, can be made into fractions, or are decimals that either repeat or terminate, which could be made into fractions. Irrationals, man, they define so easily. They're simply not rationals. So if rational numbers can be made into fractions, irrationals cannot be made into rationals. They can't be made into fractions. And I have 3 examples here. Pi, the square root of 26, and a decimal that continues on forever with no apparent pattern. So those are 3 good examples, and from there you should be able to easily choose which type of number pi or any example would be. Now we're really down to 2 last questions. Number 9, which of the choices shows these values are ranged from greatest to least? This should be a question that ideally you should use without a calculator. However, you're going to be taking this test online, and I can't prevent you from using your calculator. So having said that, here is the way we would have done it if we were sitting in class. We would make them all into the same format, and then we would compare, and that same format would normally be decimals. So using some long division or using a calculator, I turned each one of these into a decimal, And at that point, then I could pretty easily compare them. Just be careful which one it's asking for. This one says greatest to least. So the biggest one comes first. And I have 2.07, 2.8, 0.2, and 0.5. So this one should come first. And that's the square root of 8. And if I look at my choices, the first one, there's only one option that even could possibly work. So I know which one mine is. That's not really the way it should be done, but that's kind of the way it works with multiple choice. Sometimes you get lucky, and perhaps you'll get lucky. And last question. Because this is a video that's going quite a bit longer than I expected, but I am trying to review the entire year in less than 20 minutes, there are two different things that I asked you to do regularly with the square roots that were not perfect squares. We memorized all the perfect squares, your 1s, your 4s, your 9s, your 16s, and 25s, and so on. But those numbers that were in between were irrational, and you could do two things with them. You could estimate them, which is to say you could do an approximate value, and while that's not what we're asking for here, I have an example of how to estimate that on the document, so you can look at that should you need it. What we're doing here is simplifying, and when we're simplifying, we're looking for an exact equal answer. And to do that, you use factor trees. So I made a factor tree of the square root of 116. You found yourself with two numbers or a pair of 2s that ends up coming out front. You might recall that the pairs come out front and the non-pairs get left behind. In this case, the non-pair was 29 and it stays behind. And we have now simplified to 2 times the square root of 29. That gets you through the first third of the final. So 16 minutes and 42 seconds, not bad for probably 3 months worth of work. So let's call it quits for today. When I see you next time, we'll do the next chunk of stuff. And then when I see you the third day, we'll do the last chunk, which should be the freshest in your mind. And then we start the final. All right, we're almost there, everybody. So hang in, work hard and get more math. Reach out in Zoom if you need me. And otherwise, good luck.